we are asked to find the derivative of this function. Okay, I've already written it here. So let us proceed. We are differentiating y with respect to x, and the basic rule is that anytime you differentiate y, that means you're going to multiply that derivative by dy dx. Okay, so let us proceed. Differentiate 4x raised to the power of 3. We are going to have 4x raised to the power of 3 will give us 12x raised to the power of 2, according to the polynomial rule of differential calculus. Now, we have 4y raised to the power of 3. Don't forget, I told you, when you differentiate y, you multiply by that derivative by dy dx. Okay? Now, 4y raised to the power of 3 will give us 12y raised to the power of 2. Now, because we are differentiating y with respect to x, we are going to have dy dx minus, okay? Now, we have minus 2x raised to the power of 2. Minus 2x squared y. Okay, let me put minus 2. Now, let us find the derivative of x squared y. Okay? Let us find the derivative of x squared y. So when I take the derivative of x squared y, I'm going to put it inside the bracket. You understand? You see, it's simple, okay? All you have to do is just to pay attention. I'm very sure you understood how I got 12x squared plus 12y squared dy dx. Now, we move to the third term of this third term in this implicit function, which is negative 2x squared y. I'm told to differentiate negative 2x squared y. Now, in an attempt to help me to differentiate it with simple, I want to make it simple. What I did is that I just take this negative 2, I put it, and I open the bracket. By the time I take the derivative of x squared y, I'm going to put the derivative inside. Okay? So, let us bring out x squared y. X squared y. Now, we are still going to make use of product rule to differentiate x squared y. The reason is because x squared is multiplying y. So therefore, we are going to make use of the product rule. And if you want to use the product rule, this is u and this is v. And according to product rule, if you have a function uv, the derivative is derivative of u multiplied by v plus the derivative of v, derivative of u multiplied by v plus, u multiplied by derivative of v plus derivative of u multiplied by v. You can do it any other way, but I don't want you to get confused. Okay, so you can this is the formula that you're going to use to differentiate x squared y. Okay, now let us proceed. X squared is u and y is v. You understand? So u equals to x squared and v equals to y. Now I'm going to have x squared, derivative of v, differentiate y, we're going to have 1. So I'm going to have multiplied by 1 times dy dx, because I told you anytime you differentiate y, you're going to add dy dx, and if you differentiate y, you're going to have 1 multiplied by dy dx, because we are differentiating y with respect to x. This additional sign, put it there. Derivative of u, if you differentiate x squared, you're going to have 2x multiplied by y, because we are keeping v constant now, and v is what? V is y. Okay, so this is the basic ideology with respect to implicit differentiation. Okay, now x squared times 1 times dy dx is dy dx. X squared times dy dx, that is x squared dy over dx plus 2xy. You can see that it's simple. So that is the derivative. Now let us put it there. X squared dy over dx plus 2xy, okay, equals to, now let us take the derivative of 5x. That will be x. Okay, sorry. Take the derivative of 5x, that is 5. Okay. Now let us proceed. For this, I can erase this now since we are done. Okay, here I'm going to have 12x squared plus 12y squared dy over dx is equal to, okay, minus negative 2 times x squared dy dx, that is negative 2x squared dy dx, plus negative 2 times positive 2xy, that is negative 4xy equals to 5. Okay, now the next step is that you have to collect like terms. Those terms that I have that have dy dx attached to it, you will leave it at the left hand side, and then those terms that do not have dy dx attached to it, you move it to the right hand side of the equation. So I'm going to have 12y squared dy over dx minus 2x squared dy over dx is equals to, now if this 12x squared is if we move to this 12x squared to the other side of the equation, we're going to have okay, this 5 minus 12x squared. Okay, if this negative 4xy crosses the equals to sign, it's going to change to positive 4xy. Okay, I'm very sure you understood how I got here. You see, after differentiating the function, the goal is to find the y dx. Hope you know. Now, in an attempt to help me to find the y dx, those terms that has the y dx attached to it, I bring it to the left hand side. You understand? And those terms that do not have the y dx attached to it, such as 12x squared and negative 4xy, I take it to the right hand side of the equation. And if this 12x squared crosses the equals to sign, the sign is going to change to negative. And if this negative 4xy crosses the equals to sign, the sign is going to change to positive. So I have negative 12x squared, positive 4xy, and this 5 is here. Now let us proceed. Factorize the y dx. I'm going to have dy over dx is common to this and this. So put a bracket, 12y squared minus 2x squared is equals to 5 minus 12x squared plus 4xy. Okay? Now the next step is that you have to divide both sides by 12y squared and minus 2x squared. So this over 12y squared minus 2x squared. The reason why I'm dividing this is because I'm looking for the y dx. So I have to divide by 12y squared minus 2x squared, so as to enable me to I want the y dx to stand alone. You understand? So I have to divide both sides by 12y squared minus 2x squared. So this over 12y squared minus 2x squared. Okay? So the y all over dx is equals to 5 minus 12x squared plus 4xy all over 12y squared minus 2x squared. Okay, so that is the derivative of this function. Okay, so we have question number 3. We are asked to find the derivative of x raised to the power of 5 plus y raised to the power of 5 plus 3xy cubed equals to 8. How do we find the derivative of that function? We are still going to proceed the same. We are still going to proceed like we did for the 2 questions that we did earlier.